I can close this one. Yeah. Right. Next question. Sorry, next exercise. A 100 microfarads capacitor is connected in series to a 150. It's then charged. What is the total capacitance? So, this here is 100. This here is 150. So the total, 1 over 100? No. 1 over 150. Let me see. That is, hang on. That is 1 over C is, 3 over 300 plus 2 over 300. So that means C is 300 over 5, which is 60?
Yeah.
Yes.
60 micro.
Yes.
Okay. Micro. Okay. Okay. Next question. I think they're in parallel. This one is 50 micro. This one here is 200 micro. And then there's a 6-volt cell or battery here. And my question is, what is the total charge? So who remembers here, if they're in parallel, this is Q1 and this is Q2, what's the total charge? In this case, they add.
Yes.
Yeah. So look, Q equals Q1 plus Q2. But remember the formula, C equals Q over V. So what does Q equal? C V. Yes? Now, the problem here though is we do know the V. C1 V1 plus C2 V2. Okay, what's C1? If this is 1, what's C1? 50 micro times 10 to the minus 6. And what's V1? V1?
200.
No?
Also V1.
V1?
6.
6. Plus 200 times 10 to the minus 6. V2?
6.
6. What the total is, please? What is that? 254, 1250, something like 0.0125 or something?
What if you just add the C?
1.5.
That's fine. Yep.
1.5
1.5
into 10 minus 2.
10 times to the minus 6.
Minus 3.
Minus 3. Okay, so yes, if you want, that is the charge is 1.5 millicoulombs, or you could do it as micros as well, it doesn't matter. Okay. I see people writing this down. Is it because you did it wrong? Amanda?
No.
No? Okay. Next one. Number 3. A 100 capacitor, 100 micro, is connected in parallel to 200 micro. These are then connected to a 300 micro. And then there is a battery of 12 volts here. What is the charge? What I'm going to do first, yeah, I think I think I might combine things together. Yes. What I'm going to do is,
We can do it in parts.
yeah, I think we'll do it in parts.
We can do first all the
I
parallel.
think I'll put these together. 100 and 200 here. What do I get? This will be 300 micro. And here is 300 micro. Okay. And this here is 12. Right. Now, are the voltages here the same?
Yeah.
Well, usually no, but in this case they are. Why? They're usually not the same. They're different. In series, the voltages are different.
Because you took it from the parallel.
No, no. Guys, look up, please. Please, look up. If I put a voltmeter here, and I put a voltmeter here, are these voltages normally the same or different? Different. Now in this example, I think they will be the same because they are the same. 300 and 300. But they're normally different. Okay. What do I want to do? I know the C. Do I know the V? No. I think I'll put them together again. Right, so 1 over C equals 1 over 300 plus 1 over 300. So that means C equals 150 micro. Is that right? Yeah? 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 Okay. So now I have this 150 micro and 12 volts. So now I can calculate the charge. What does Q equal? What's the formula? CV, which is 150 10 to the minus 6 times 12, which equals
1.8 power to minus 3. 10 times minus 3.
yeah? Okay, now that's not finished. I didn't ask for the total charge. What did I ask for? I asked for the charge on each of them. So now I need to go backwards. Okay, so this answer is important. Please note it. Let's go backwards. Can I go back? No. Not yet, okay. Can I go back? Yeah. So look, if I go back to this step, this is charge Q1 and this is charge Q2. What is the total charge?
1.8.
Hang on, no. Children, focus. Look up here. I have charge Q1 and I have charge Q2. What is the total charge here? Thank you. Q is equal to Q1, which is also equal to Q2. Now, do you know the total charge? Yes. There it is there. So, both of these will be the same. Oh, please, listen. These are not the same because these are the same. If this was different, these are still the same. We said that in the last lesson.
Yeah.
Okay, good. Now, this one here is, what did I say, 1.8 millicoulombs, and this one here, 1.8 millicoulombs. Alright, let's go back up a step. So how big is this one? 1.8 millicoulombs. And how big are these two together? 1.8 millicoulombs. Yeah, now let me call this one here, I'll call this one now Q1 and this one here Q2. What's the total charge?
Q1 plus Q.
That's right. The total charge equals Q1 plus Q2. 1.8 times 10 to the minus 3 equals C1 V1 plus C2 V2. Now, do we know the C's?
Yeah.
We do.
Yes.
100 and 200. Do we know the V?
Yes.
No. Because this voltage is 12. But we don't know how much each of these are. Maybe this is 6 and maybe this is 6. Or maybe this is 9 and this is 3.
But won't be overall it will be the same because of 3 and total is 2.
No, I'm saying if I had a voltmeter here, it won't be 12.
Mm.
Okay? But what do we know about V1 and V2?
You can calculate the V2 and then use the total V2 minus V2
You
and
could. Something, yes, a little simpler though.
V1 plus V2 equals to 12.
No, it does not.
It's
V1 equals V2. That the voltage here and the voltage here, they're the same. Sorry, I should have been clear. When I say V1 and V2, I meant this one and this one. Because of my formula, Q1 and Q2. These are the same. Agreed? Yeah. So now I have 1.8 times 10 to the minus 3 equals 100. 100 times 10 to the minus 6 plus 200 times 10 to the minus 6 V. So I get now V equals 1.8 times 10 to the minus 3 over 300 times 10 to the minus 6. So I get V equals 6? I don't know. Actually, what do I get for V?
6.
It is 6. Great. Now I can finally get Q1. Q1 equals CV1 and Q2 equals C2V2, which is 100 times 10 to the minus 6 times 6, which is 100 times, sorry, what's this, 200? 200 times 10 to the minus 6 times 6. So finally, Q1 equals, Q2 equals. What's Q1?
6 multiplied 10 minus 4.
6 times 10 minus 4, 12 times 10 minus 4. This question was quite difficult because you have to go all the way to the end and then you have to go backwards. A very good exam question for revision because of everything you had to do. What did I say, KJ? Because? Fantastic. Alright, can I go to the next question? Question?
V equals 6 is the way.
Sorry, yeah.
Is 6.
This is 6 volts and this one here is 6 volts. So Amanda, you said you can take them from 12, so therefore how much is this one?
6.
6 also, yeah. Okay, can I go to the next one? Yep. Right, this one actually is a little easier. I should have actually swapped it around. This one is 150 micro. That is the capacitance, and the charge is 150 milli. So my question then is, what voltage would I get? So C equals Q over V, V equals Q over C. So V equals 150 times 10 to the minus 3 over 150 times 10 to the minus 6, which equals 1000 volts, which equals 1 kilovolt. Yep. One more question. Okay, Amanda, can I go on? Faster, faster. Yes. All right. A 200 micro is connected in parallel with a 300 micro, and then what I do is I connect a, how big of a battery? 5-volt battery here. So firstly, they're fully charged up. Okay. So here, what's the charge? Q1 equals C1 V1, which equals 200 times 10 to the minus 6 times 5, which is 10 minus 4. Is that right? Can someone check that, please? And then here, Q2 equals C2 V2. Is that right? Minus 4.
No, 1 minus. Yes, I right.
It's right. 10 to the minus 4.
Yeah, it's 1 into
3.
No, 1 multiplied.
Oh, sorry. 3.
The same thing.
3.
No, the same thing.
Yeah, 3.
But yours is 10.
No, that was wrong.
No.
This is right. Thank you, Amanda. 3. Okay. Which is 1 millicoulomb. 1 millicoulomb. Okay, here, this would be 1,500 times 10 to the minus 6, which is 1.5 times 10 to the minus 3 coulomb. So that is 1.5 millicoulomb. Yep. So this is my first answer, and this is my second answer. Now this isn't finished yet. There's more to it, but that's the start. Okay, can we look up now? Or do you need a minute? Yeah? Okay. Now, if you look here, what's happened is this. Let's just say the current was going this way. So what has happened is this one has become positive, this one has become negative, this one has become positive, this one's become negative. So this one here has 1 millicoulomb, and this one here has 1.5 millicoulomb, and this is positive and this is negative. But then in the question, this one's positive, sorry, this one's negative. In the question, I then say, you take the smaller capacitor, look at me. You take the smaller capacitor and then you turn it around. So now it's like this. So what will happen is this negative charge will find this positive charge, and what happens? They cancel. But they don't completely cancel, because the bottom one is bigger than the top one. So now what you're left with is this. This one here has no charge. And how much will the one at the bottom have?
0.5.
Yes, 0.5 millicoulombs. Yes? Okay. Now what will happen is this will start to lose its charge. And then what will it do? It will start to charge this one.
Then we equal that.
And then they will be, well, we don't know if they'll be equal. They might not be equal, but they will balance. So I think my question is, what is the voltage you get here? That's all I ask. So we can use our formula Q equals CV. V equals Q over C. So the voltage we get as it's discharging is 0.5 times 10 to the minus 3 all over 300 times 10 to the minus 6, which is what?
5 over 3 volts.
Yeah, exactly 5 over 3.
Yeah,
1.667 volts. Is that right, KJ? You're not happy with that? Yeah. I've seen this one in the exam. That's why I wanted to do it. Now, true, this was a bit of a difficult one in the exam. Can I go on? Yes?